Hello everyone, in this video we are going to solve a really interesting problem from IIT JEE 2011 paper 2. Problem is about two batteries of different EMF and different internal resistances connected in parallel. This is battery 1 and this is battery 2. Their positive terminals are connected at A and their negative terminals are connected at B. We want to find the common voltage VAB, which is VA minus VB. So let's find the common voltage VAB. So the two batteries terminal connected together in parallel, they will form a closed loop. So current I will flow since the EMF of both the batteries are different. So because of the difference in the EMF, current I will flow through the circuit, which will be common to both the batteries, and it will also flow through the 1 ohm and 2 ohm resistor. So our first approach will be to find this value I. So we will use Kirchhoff's voltage law to find the value of current I. So we'll write the expression minus 6 plus 3 plus 2I plus 1 into I equal to 0. So this will become minus 3 plus 2I plus I equal to 0. So 3I equal to 3, I will be 1. So current I will flow through the circuit, which is the common current flowing through the batteries when they are connected in parallel. Because we want to find VAB and that is common for both the batteries, so if we will take one battery and write the KVL expression, then if we will calculate VAB for one battery, that will be same for the other battery. So we will calculate the VAB for both the battery and we should be able to get the same value of VAB for both the battery, and that would be our answer also. So this is battery 2 VAB. So let's write the expression for battery 2, KVL equation for battery 2, and then we'll write for battery 1. So using KVL we will get minus VAB plus 3 plus 2I equal to 0. So VAB equal to 3 plus 2I equal to 0. We will use the value of I that we calculated. This is the common current that is flowing through both the battery. So plugging the value of I, we will get VAB equal to 5 volt. Similarly, if we will try to find the VAB for battery 1, we should get the same value of VAB, that is 5 volt. So we will write the KVL expression for this also, keeping in mind the direction of current which is going from B to A. So using KVL we will get I into 1 minus 6 plus VAB equal to 0. So using the value of I equal to 1 in this expression, we will get 1 minus 6 plus VAB equal to 0, that is VAB equal to 5. As expected, the common voltage VAB is 5 for both the batteries as they are connected in parallel, and VAB is their common terminal. So finally we have calculated VAB to be 5 volt. I hope this solution was clear. Don't forget to like, share and subscribe for more such videos. See you in the next one. Thank you.